Okay, we're going to draw a cone frustum cut, a top and bottom, a right cone. So we'll start first by drawing the cone itself, then we'll see how we are going to develop these cone frustum cut, a top and bottom. So first we draw the cone. So this is a right cone. The height will be at the center of the cone and perpendicular. Okay, so this is our cone. Is it truncated? We are going to show how we'll do the cut. So before we draw the cut, let first, because I need a certain position of the cut. I don't want to cut now. I'll draw first the semicircular divided in 6 and have the projection. Then from there I'll see the position of the cut. We still use the parallel line method. So let's subdivide like usual. Going to project. First we project perpendicular to the base. Okay, we'll number them. This is 1, this is 0.2, 0.3, 0.4, 0.5, 0.6 and 0.7. Now we draw the projections. To the apex. Okay, so this is the cone. Let's call the apex point X. So before we cut, you have first to get the full cone developed. It's very important, because on the development you will have the true length, then the cut will come from the true length. Now in this case we are going to draw first the full cone development, then I'll show the cut. Now when you have the cone like this, what we have to keep in mind is, you see we have 1 2 3 4 5 6 7. The only line which is true length is xy, x1 and x7, because these are the faces of the cone. The other intermediate lines are not true length. Okay, now let's draw the true length. So we develop the cone. Let's say, if we say our point is here, so we'll take the true length. This is our point X. We take the true length of this side. Is we can take 1/7, I mean x7 or x1 is the same. All right, now for instance, I say I want this is okay. You see, for instance, this is x7. You see x7, I've drawn the line x7, x7. Now I'll subdivide. I have to take this distance from 7 to on the semi-circumference, because the base of a cone is a circle. Now I can take this distance here, 6 to 7. Now from 7 here, I'll mark off on my scrubbed arc. Okay. Now see, this is 7. We have 6, 5, 4, 3, 2, 1, 7, 6, 5, 4, 3, 2, 1, 2, 3, 4, 5, 6. We need an extra one. First we extend. And then we take the same gap. There we go. So we have our last point here, 7. Now I'll join all the, so these lines that I'm drawing on the development, they are true length. You see here, x6 up to the base is not a true length, x5 is not a true length, x4 is not a true length, x3 is not a true length, x2 is not a true length, but here all the lines will be true length. So all of these are true length. Now let me show the cut. So if my cut, I want my cut to start here between 2 and 3. So this is the bottom cut. We'll have to cut. This is the bottom cut. All right. Now already this point here is not, you see, we have the starting point of a cut is here and the other one is there. So I have to make sure that I know the position of this point here. How do I know it? I have to project it on the, I project it on the semicircular, the semicircle. So this is point Y. Now what is the position of point Y here? Okay, so Y is between 3 and 2. So I'll take this distance here. From 3 to 2, that is my Y. From 3 to 2, this is my Y. Okay, I have Y here, I have Y there. Now this cut 3 here, cut 4 here, cut 5 here, cut 6 here, and cut 7 there. Now 3, 4, 5, 6, they are not the true length, but x7 is true length. So for me to get the distances from x to the cut, 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 I need to project them horizontally to the true length, which is x7. That way I'll get the true length. Okay, now I have this intersection here. So this is intersection with 7, intersection with 6, intersection with 5, intersection with 4, intersection with 3. So these actually are the distances from x to 7, from x to 6, from x to 5, from x to 4, from x to y. Now I have to take these distances here with my compass and I show them there. So let's start with 7. Now from x to 7, this is the true length of the cut. Now I'll come from x to 7. This is the length. Now from x to 6, this is the true length of the cut. From x to 6, then x to 5, now I'm on the line x5. From x to 4, on the line x4. Now from x to 3, right, now these are the distances here. I pick up, you remember this is the cut, I project all here so that I have the true length, then from there I report them this side. Now what about point Y is already there on the base. Point 2 and 1 we don't move them because them 1 and 1 they are not cut, so they're still at the base, the rim base. So it will be 1 is still there, 2 is still there, Y is still there, then from 3 then we have to take the curve. Now let it draw as the curve. Now from Y it will still have the same, so Y to Y. All right, so this is this cut here. Now let's have another cut on top. Let's say if this cut is at this level here, all right, so this is the cut at the top. Now again we remember that x1 is true length, x7 is true length, all the other lines intermediate, they are not true length. So for us to have the intersection with the cut, you have to project all these distances, the cut to the x7 horizontally, because x7 is true length. Then from there we'll take all the values. This is for 1, you can even leave it there, you just take it from the side of x1, but it doesn't matter that we have projected to this side. Okay, so we have 1, x to 1, x to 2, x to 3, x to 4, x to 5, x to 6, and x to 7. So these distances again, this length, I'll take them with the compass for x to each and every distance. I'll start with x to 1. Okay, this is x to 1, so easy. Now x to 2. Now x to 3. X to 4. X to 5. X to 6. X to 7. Okay, this is x. Now we have all the intersection. We can join them. It's better you go with 3 points at a time. very done. This is our cone frustum cut at top and bottom right corner. Okay, thank you.